So let's turn to page 21, okay? The topic is called radical. In other words, it's a square root, cube root, okay? Any kind of root. So radical is the symbol, okay? This symbol here. And then outside, this number is called the index. So depending on the number you put there, if it's a 2, we call that square root. If it's a 3, cube root. If it's a 4, you just call it fourth root, okay? But then that symbol is called a radical sign, okay? So let's just quickly go through what kind of content is inside this chapter. So first we'll talk about some terms, okay? And then second part is how to simplify it, simplify radicals. And the part C is operation. Operation means it could be adding, subtracting, multiply, divide. And then part D is called rationalized denominator. Part F is equations. Okay, so total of 5 parts. We have word problems too. Okay, so 6 parts. So let's go back to the beginning here. So usually when we say square root, right? For example, like square root of 16, you just answer 4, okay? But in fact, there are more, yeah, Shanier. Your whole entire page is blank. Page 21, you mean? Okay, other page, you have it? Only missing 21, is it, Shanier? Yeah, so probably just miss a page when they photocopied it. So you can take the notes on a separate sheet of paper, okay? And then just glue to the book, okay? So here we'll look at more detail of the terms, okay? Because usually we just use the word square root loosely. Okay, so for example, if I have a number and then we do 4, and then we square this number, we will get 16. Okay. So here's the question, is there another number? And then I also square can give you 16 as well. Is there another number that could also work? Aaron, what do you think? Other than 4, is there another number square also gives you 16?
-4.
Very good. Okay, so negative times negative can give you positive 16, right? So the other possible answer will be the -4. No. So you always have one answer that's positive, one answer that's negative. When you square, give you 16. So the numbers that works are called the square roots. Okay, so we'll say the square root of 16, we have 2 of them, are 4 and -4. Okay, or you can say plus minus 4. So there are always 2 square roots. So if they say, please find the square roots of the number. So for example, like question 1a, for 25, it will be 5 and -5. So you can write plus minus 5. Okay. So the 4, okay, so the number 4, okay, I'm going to change the notes a little bit, okay? Instead of writing the square there, I'm gonna write it on the arrow, okay? Square. Okay, so 4, if you square that, it'll give you 16. Negative 4, if you square, okay, will also give you 16. So they design a symbol to represent each root, okay? For the positive square root, they just write radical of 16. Okay, so at the front is positive, okay? You could show it or you don't show it. Usually we don't show the positive sign, okay? But I'm just writing out. So then it represents the positive square root, okay? And then for the negative square root, because you have always 2 of them, right? One positive, one negative. For the negative 4, then you put a negative in front. So these 2 things, okay, the one I box here, these are called the square roots. So there are 2 square roots of 16, okay? You have a positive square root of 16 and a negative square root of 16. So sometimes they ask for square roots, then you need to write both. But if they only give you one of them, for example, if you look at question 2A, right? If you look at question 2A, this one is the positive square root. So for the answer of 2A, you don't write it out as plus minus 0.6. Okay, you will just say this one is the positive one, right? Because there's no negative at the front. So the answer is just simply 0.6. Okay, you see a difference? In question 1, it doesn't show the radical sign, okay? It just say find the square roots of the following numbers. So you need to write both of them. Of part 2, it only asks you to evaluate. So depending on whether they give you a positive or a negative, for example, like question F, this one has a negative sign in front. So the answer is just negative 4. Okay, it's asking for the negative of the square root. All right, so I'll let you guys complete the following 2 questions. Okay, part 1 is find the square roots, part 2 is evaluate. So remember which ones needs plus minus sign, which ones you don't need plus minus sign. Okay, so when you finish 1 and 2, you can raise your hand. These are pretty straightforward, okay? Just find the square roots, either positive or negative or both. Okay, just on the side, if you see a little 3 on the side, on the index, it means cube root, okay? So for example, like cube root of 8 will be 2, okay? And if there's a number before the root, that just means it's multiplying. For example, if you see negative 5, and then they don't need to show the times, okay? Negative 5 and then cube root 8. Then what that means is negative 5 times 2. Okay, the number in front is multiplying with the answers from the root. Okay, so you get negative 10. Okay, so these are just 2 examples. If you run into other kind of index, okay, so when you finish exercise 1 and 2, you can raise your hand.
Mr. Jason,
Yeah, Kat,
can I go to the bathroom?
sure.
Thank you.
You're welcome. Okay, we'll check question 1 first. Okay, Naomi, what are the square roots of 400?
Plus or minus 20.
Yep, plus minus 20. Good. All right, question C, Henry.
13, positive, negative 13.
Yep, good. Okay, so when they ask for square roots, you need plus minus. Bernice, question D.
Plus or minus 21.
And yeah, question E.
Plus or minus 14.
Okay, good. Okay, question B. For question 2, exercise 2B. Okay, Valerie, what do you have?
0.81.
Yeah, 0.81. And Jenny, C.
I have 16.
Yeah, good. And question D, Aaron.
I got 0.2.
Isabella, next one. Question E.
Negative 0.9.
0.9.
Yeah.
Okay. And F, we did it. Okay, question G, Angeline.
3,000.
Yeah, 3,000. Okay. And H, Bernice.
I got 50.
Okay, very good. Okay. Okay, Geoffrey, have you got to I?
2.
2, very good. Okay. Yeah, so this one is a double square root. You start from inside. Okay, square root of 16 and then square root of 4. Okay, give you 2. Cube root, we did it on the top. Okay, that one is a 2. Okay, question K. Mackenzie, do you have question K?
It is
Can I try?
Give him another minute.
negative
What'd you say?
negative 15.
Negative 15, very good. Okay, we have a cube root of negative 105, 125. That one is negative 5. Okay, -5 times itself 3 times can give you -125. Okay, and then you multiply. All right, Tony, last one.
Okay, the last one. 15.
Yeah, okay, so 5 times the 3 give you 15. Okay, so this part shouldn't be difficult, right? So you just find a square root. Most of you have seen it before. Now there's one more thing I want to mention, okay, is questions like B, okay, you can put the star there, H, okay, these ones, let me see, that's all, okay, so if we go to the top, okay, you see I have a small empty space there, okay, so what those two questions is telling you is sometimes if the inside of the square root, if I have a number, let's say 3, and I square that, okay, I put a 3 and a square, which is the same as square root of 9, which gives you back to 3. Okay, so the square and the square root, they kind of cancel each other out. Okay, so when you see a square inside a square root, okay, the answer is just whatever that's left inside. Okay, so that's the first part. Sometimes the inside could be a negative number, but you need to have a bracket, okay, like question H. If you look at a question H, if we have -3 squared, okay, you see I keep the brackets. So that means when you square that, it will give you +9 on the inside again. So of course the answer ends up as 3 again. Okay. So square and square root, when you see them together, always makes the result positive. So therefore, they design another symbol to represent square and square root when they are together, like a combo. Okay. So let me use the different color. So when you see square root paired up with square, like this one, or the second one, okay, it will be the same as having a 2 bar. Okay, so 2 bar, for example, if I put 3, it will equal to 3. Okay, if you put -3, will also equal to 3. Okay, so when they put 2 bars around the number, it's doing the same thing as having a square and a square root. Okay, so you can write this down, plus, minus. So those 2 bars, does anyone know what that called? What we call that, the 2 bars? Has anyone seen it? Kat, have you seen it before? The 2 bar beside the numbers?
Oh, no, I have not.
Does anyone know? Shanir, have you seen it before? Yes, okay, it's called the absolute value, all right? So you can write this down. So we will say absolute value of 3 is 3. Absolute value of -3 is also 3, okay? So this symbol here, the 2 bar, is called absolute value. Okay, they put it here because it has to do with the square root as well. Okay, so on the very top, because I'm running out of space, okay, I'm gonna put it on the top. So whenever you see square root and square, it doesn't matter what's inside, it will just equal, right? You can change it to absolute value of whatever that's inside. Okay, they mean the same thing. You can box that, okay? So next time, if you see this 2-bar symbol, okay, don't be surprised, right? It just means the same as square and a square root together. Okay, so we have 2 examples down here, right? Question B, question H. Right, so question B, 0.81 just stay the same. Question H, the negative 25 becomes positive 25. So you can write it like this. Okay, equals to 2 times 25. Okay, this is for question H. I can change that into absolute value. For question B, same thing, I'll change that into absolute value, 0.81. Okay, so because it has to do with square root, okay, that's why we go over this one. All right, so if you got all the notes down, okay, especially this absolute value part, can you raise your hand and then we'll move on to next page. Does anyone have question that feel confused about absolute value? So this page we just learn, okay, you need to understand the symbol, that's all, okay, how to read the symbols. Okay, after copying down, please raise your hand. This absolute value only work for square, okay? Square and square root. So if you have like cube root and cube, you cannot turn it into absolute value, okay? Because it doesn't guarantee it will be positive, okay? If you have absolute value, whatever that comes out will always end up positive. Okay, Shanier and Tony, do you need more time to write?
I'm good.
Yep. And how about you, Shanier? Okay. All right, so let's go to next part. So next part is also kind of like explanation, okay? Not much calculating, right? So this part is talking about simplified radical. So the instruction on the homework, okay, if you look at next page, they will just say simplify, okay? Simplify the following radical. So what does it mean when they say simplify? That's what we are trying to go over here, okay? How do we know if the answer is already the final answer, right? Just like when you do exponents, right? How do we know when to stop, okay? If they say, please simplify the radical, how do I know that's the answer? So there are 2 conditions that you need to check, okay? So when they give you a square root or a cube root, okay, this one is the square root. Okay, this one is the cube root. If the radical satisfy the following 2 conditions. First one, there is no perfect square or perfect cube. Inside. Okay, if it's a square root, then you don't want to have perfect square. If the question has a cube root, then you don't want to have perfect cube inside. Okay, I'll explain the second condition later. Okay, right now I just write this down first and I'll explain what that means. All right, so let's take a look at an example. So perfect square, okay. Let's understand this term, perfect square. are numbers that when you find the square root, it stops, okay? It doesn't, the number doesn't go on forever. For example, like 16 is a perfect square because the square root of 16 is plus minus 4, right? It's not a decimal that goes on forever. So for example, you could have 4, right? 9, okay? 16, those are all perfect square, etc., right? You could also have decimals. That's perfect square. For example, that you saw on last page, you could have 0.09, right? You could have what else? Do we have other decimals? That's also perfect square. 0.36, right? Like question A, okay? So it's not limited to whole numbers, okay, etc. So perfect cube means the numbers that when you cube root it, it will stop. Okay, so can you give me an example of a perfect cube number? Okay, Henry, can you give us an example? Perfect cube.
27.
27, very good. Okay, so cube root of that will be what?
3.
Yeah, very good. Okay, and we can have even like one is also perfect cube, right? It's a perfect square as well, right? Or 8. Okay, let's have a decimal example. Geoffrey, can you give us a decimal example perfect cube?
0.08.
0.08. What's the cube root of that? Geoffrey, what's the cube root of?
Wait, 0.008.
Okay, 0. So 2 zeros.
Yeah.
So what's the cube root of that?
By 0.2.
0.2, yeah, 0.2. Okay, so decimal a little bit tricky, right? Because when you multiply, you get more decimal places. Okay, let's get one more. Okay, one more cube root, perfect cube. Okay, Wilson, what will be a perfect cube that is a decimal?
Let me think.
Yeah, take your time.
Give me a second. Once I have the answer, I'll give it to you. One moment.
You can just come up with any decimal and then times itself 3 times.
Is 0.125 a perfect cube?
0.125. Then what do you think the cube root of that is? What's the cube root of 0.125?
Oh wait, never mind. No, it's not. 0.125 isn't perfect cube. Actually, I'm not quite sure. Hang on.
Okay, we can come up with a, let's check, okay? Check if 0.125 is a perfect cube or not, okay? If it's just 125, what's the cube root of 125?
125 is 5.
Yeah, so let's say if we had decimal, 0.5. What's 0.5 square?
2.5.
Can you multiply by yourself? 0.5 times 0.5. How do we do that?
Is it not 2? Is it 2.5?
No, you have to do 5 times 5 first, right? What's 5 times 5?
25.
25. So you put 25 first, and then you count the number of decimals we have, decimal places.
It's 0.25.
Yeah, 1, 2. So you count 1, 2, 0.25, right? Now, if I add in one more, 0.5 cube.
Oh yeah, then then it's 0.125.
Yes, okay. So basically to find a perfect cube, you just pick any decimal number and you take that number times itself 3 times, okay? Then the result is a perfect cube. Okay, so you can make up anything. All right, so now you understand the perfect square, perfect cube, okay? So if I give you the radical, we want to see if that radical has a perfect square or cube or inside or not, okay? So we need to check. So for example, if I have a square root of 25, okay? So you look at the inside. This is a perfect square. Right? So therefore, it's not simplified. Because you cannot have, right? There's no perfect square inside. So this one is not simplified, okay? We'll just write out a few examples. Now let's look at next one. Let's say if I have square root of 20. Okay, is 20 a perfect square? Isabella?
No.
It's not, right? Okay, so right now it looks like this one is not a perfect square, so no perfect square inside. So it looks like it's not simplified. No, I mean, it looks like it's simplified because there's no perfect square inside, right? But inside the 20, I can break it apart into factors. With factors of 20. Okay, so what we do is we draw a box like that and then use numbers that can be divisible into 20. Okay, so we can use 2, right? 20 divided by 2 will give you 10. I can also divide by 2 again, give you 5. And then you stop when the last number is a prime number. Because the 5 can only be divided by 5, nothing else. Okay, we call that a prime number. So from here, we know that the 20, we can write it as 2 times 2 times 5. And inside here, the 2 times 2 is a perfect square, right? 2 times 2 is 4. 4 is a perfect square. Okay, therefore, it's still not simplified. Okay, so even though at beginning, the 20, it looks like it's simplified, right? There's no perfect square. But then once you break it down, there are perfect square hiding inside. Okay, so when you are not sure, you have to break it down. Okay, let's try one more, right? So try another example here. Let's say we do a cube root, okay? Do a cube root one. So cube root of 54. Okay, so cube root of 54 looks like it's not a perfect cube. Okay, so let's break it down. So I'll let you guys do the box by yourself. Put 54 and think about the numbers that can go into it. The number usually we use prime numbers. Okay, you start with a 2 and then keep on dividing. And then break down into prime factors. Okay, so please write out the factors of 54, okay? After you got the factors, please raise your hand. Okay, Bernice, what number did you use to divide into 54?
So I first divided by 2, and then I got 27.
Mhm.
So then 3 times 3 times 3 is 27.
Okay, very good. Okay, so if I keep on dividing, it will be 3, 3, 3, right? So you have 3 times 3 times 3 times 2. So because this question is a cube root, so we try to find perfect cube. Perfect cube is hiding inside of 54, right? There's a 27. This is a perfect cube. So if you are able to find either the perfect cube or perfect square inside the cube root or square root, then you will say this one is not simplified. Okay. So if after you break it down and you still cannot find anything, right? There's no perfect square, no perfect cube, then the question is already simplified. You don't need to do anything. Okay, so this part is just checking whether the question, the radical is simplified or not. Okay, do we have any questions about how to check? Okay, so this is the first condition, okay? To check if there's perfect square in the square root or perfect cube in the cube root. Okay, you want to make sure there's nothing inside, hiding, okay? Second one, also no, okay? You want to make sure there is no radicals. Okay, so here I just say radicals. So radical includes square root, cube root, okay, any kind of root in the denominator. So this one is very straightforward, okay? Nothing to check, you just take a look. For example, if you see something like 3 over square root 7, right? There's a radical in the bottom, right? Denominator. So that means this is not simplified. Okay, so this is just answering yes or no, okay? Yes means it's simplified. No means not simplified. Okay, so if it's no, please write down the reason, okay? Why you think it's not simplified. So at the bottom, we have 8 radicals questions, okay? So please check, determine if the following radicals are simplified or not. So you answer yes or no. If it's no, then you just say why, okay? So the reason, for example, you could say like if it's the second one, right? You say, oh, there's a 4 factors of 4, right? Inside 20, okay? And then if it's this one, you can say denominator has radical, okay? Those are the reasons, right? So I'll let you check the following 8 questions. When you're done these 8, please raise your hand. If it's yes, then you don't need to say any reason, okay? Okay, I'm going to write the names on the screen. Okay, you can answer, write down yes or no. Okay, we'll talk about the reason, right? Please raise your hand if you're done. Okay, you can begin writing your answer on the screen if you see your name there. Okay, how about you, Tony? Your question is question E.
Oh. I'm not too sure.
Yeah, just think about yes or no. Is there perfect perfect square inside, hiding inside? If it's simplified, then you cannot have any perfect square inside, okay? If you're able to find the perfect square inside, then it's not simplified. All right, let's go over each one. Okay, I'm gonna use red, okay? So for question A, the 4, right? Inside, I see a 4. 4 is a perfect square. Right? Perfect square. So there's a perfect square inside, then it's not simplified. So answer is no. Okay, you're correct. Just little thing here and yeah. Okay, for square root, if you have square root of 4 at the front, it's empty, right? Nothing at the front. So that's only the positive root. Okay, so if you want to find the answer for that, answer should be just positive 2. Okay, not the negative 2, not plus minus. Yeah, okay, very good. Okay, second one, the 2 Okay, that one is not a perfect square, right? And there's nothing hiding inside. Okay, so no perfect square inside. So yes, yeah, it's simplified. Okay, yes means it's done. Okay, yes means root 2, nothing else you can do. That's it, right? Okay, for 24. Okay, question C. Geoffrey, why do you think it's not simplified?
Because square root of 2 times 2 times 2 times 3. And there's a square root in there.
There's a perfect.
There's a perfect square in there.
Okay, so we can break it down into 2 times 2 times what?
2 times 3.
Okay, so perfect square, what's the perfect square that's hiding inside?
The 2 times 2, like this part.
Okay, very good. Okay, so 2 2s, so that's a 4, right? So this one is a perfect square. Therefore, is not simplified. Okay. Now for question D, okay, for Wilson, this one, okay, if you look at the whole thing, do you see square roots? Question D, Wilson, do you see square root?
I had a square root on it.
There's a square root, right?
Yes.
Is that square root in the numerator or denominator?
Denominator.
Okay, so the moment that you see the square root in denominator, then you know it's not simplified. Okay, so we don't really care about what's inside the square root. You want, if you see the location of the square root in the denominator, right, then it's not simplified. Okay, so sometimes you need to look at the inside, but if it's a fraction, you just look at the denominator. All right, question E. So 34, how do you break down 34 into factors, Tony?
Pardon?
How do you turn 34 into factors?
You can do the factoring method
Yeah, and what factors do you find?
like this, and then you put 34 like this.
Yeah, so what numbers goes in?
2 and 1.
2 times 17, anything else?
No, I don't think so.
Yeah. Okay, so do you see any perfect square inside?
No.
Okay, so answer is yes. Very good. Okay, this one is simplified. Okay, Henry, do you see square root? Henry?
Yes, but hello?
Yeah, do you see square root in the numerator and the denominator?
Yes.
Yeah, okay. So if there is a square root in the denominator, what does that mean?
Do you? I'm
Is
not
it
sure.
simplified? Is it simplified?
So no.
Yeah, answer should be no, okay? Just same as question D. You don't need to check what's inside or not, okay? If you ever spot square root in the denominator, right away is not simplified.
Okay, I understand.
Yeah. So later we'll learn how to simplify, okay? Right now, you just need to recognize which question is done, which question is not simplified yet, okay? Right, so for question G, 24, okay, how do we turn 24 into factors? Oh, we did that up there, right? So cube root of 24, so we have 2 times 2 times 2 times 3. So Jenny, why do you think it's not simplified?
Because there are three twos.
Very good, okay, 3 2s, that makes it a perfect what?
A perfect cube.
Yes, okay. If you can find the perfect cube inside, then it's not simplified. Okay, let's look at last one. Last one, we have 126. Okay, so Isabella, you say not simplified, right? Did you break it down, the 126?
Yeah.
Okay, what does it break it down into?
2,
Yeah,
3, 3, 7.
3 and 7. Let's see. So 2 times 3, 6. 6 times 3 is 18. 18 times 7 is 126. Okay. So what are we looking for? This is a cube root. So you should be looking for perfect what?
Cube.
You see perfect cube inside.
Yeah.
Where?
The 2 3s.
If you have 2 of them,
Oh, wait.
that's called perfect square. Right? Because 3 times 3 is a 9. That's a perfect square. You need to have 3 of them the same to be called a perfect cube.
Then no.
Yeah, okay. So no perfect cube inside. So in fact, this one is yes. Okay, it's simplified. Simplify means nothing else you can do to the question. Okay, cube root 126 is just gonna stay like that forever. Okay, nothing you can do to change the look. So if it's not simplified, then we can still do something, okay, which we'll learn later. Okay, so this page, this exercise is just learning how to recognize which question is done, okay, which question there's more work to do, okay, simplified or not. Okay, we'll have a break and we'll continue at 2:45, okay? So if you have questions, still have questions about this part, you can ask me during the break.